Hello, I welcome you all in this presentation related with the subject fundamentals of surface engineering, and we are talking about the different methods used for developing coatings. And under this process or for this purpose there are various thermal spray processes about which we have talked. In addition to that, we will be talking about the plasma spray process under the thermal spray process category. Thereafter, we will be taking up the two other processes like electroplating and electroless plating. These processes like electroplating is based on the electrolysis, and electroless plating process is based on the chemical reactions for developing the coating of the suitable material, so that the improvement in surface properties can be achieved. So, if we see the plasma spray process, plasma spray process basically as we know that the plasma spray process basically the plasma is created using suitable gas like plasma forming gas, which may be in form of argon or the nitrogen. Now, this plasma forming gas is allowed to flow through the arc. Now, this arc can be established between the electrode and workpiece or the substrate. This is the case of the transferred plasma arc, or the arc can also be established between the electrode and the nozzle. So, in this case the plasma arc is independent of the workpiece. So, in this case workpiece is a part of the circuit. Electric circuit workpiece is the part of electric circuit, and here workpiece is independent. So, there is independency with regard to the distance between the plasma spray torch and the workpiece. So, it is independent, and so in the plasma spray process basically non-transferred plasma spray method is used, which means there is one electrode and there is nozzle, and this nozzle and arc is established between the electrode and the nozzle. So, electrode is primarily tungsten, which is connected to the negative terminal, and the nozzle is connected to the positive terminal, and then plasma forming gas is supplied, so that this plasma forming gas passes through the arc, and then this plasma is passed through the nozzle. So, this nozzle is of the small diameter opening, you can say orifice. So, small diameter orifice is there in nozzle, which constricts means reduces the diameter of the plasma which is flowing through the nozzle, and so this constriction increases the energy density of the plasma, and then in this plasma we feed the suitable coating material. Normally it is fed in form of the powders. So, in the plasma we feed the material to be coated. Since the plasma is at a higher temperature like 400 to 4000 to 5000 degrees centigrade, so all the material is brought to the molten state. Since the plasma will be moving at a very high velocity, so the particles will also be moved at a high velocity and they will be accelerated towards the surface of the substrate. So, basically the particles, powder particles of the material to be coated in the molten state are accelerated at a high velocity towards the substrate, where after the impingement they get flattened and form a splat. So, deposition of the material splat by splat onto the surface of the substrate after the solidification leads to the development of coating. Since the temperature is quite high, so it can be used for developing the coatings of high temperature material. So, this is the basic principle of the plasma spray process. Basically, the plasma forming gas is allowed to flow through the arc, so that the plasma is created, and this plasma is forced to pass through the nozzle, where it is constricted. In the nozzle we feed the material to be coated, so that plasma heats the powder particles to the molten state, and these powder particles in the molten state then subsequently accelerated towards the surface of the substrate, and after the impingement with the surface of the substrate it forms the splat, and deposition of the material in form of the splat. So, splat by splat deposition onto the surface of the substrate takes place. Now, there are some of the issues, like the velocity is not very high in case of the plasma spray process, and the temperature high temperature is experienced by the material. So, there is a possibility of the thermal damage of the coating material in form of the oxidation or interaction of the material with the gases which are present, as well as undesirable metallurgical transformation. Undesirable metallurgical transformation. So, we cannot do much, except that we cannot do much with the undesirable metallurgical transformations in the plasma spray. That is why we should avoid the development of those coatings where such kind of the undesirable metallurgical transformations can take place by the plasma spray. But certainly something can be done to avoid the thermal damage in form of interaction of the coating material with the gases present in the plasma zone or during the spray process. And for this purpose only, what we do with the plasma spray process is carried out in very controlled environment. Controlled environment. So, when the plasma spray is carried out under the atmospheric conditions, we call it air plasma spray, and when the plasma spraying is carried out under the vacuum conditions to avoid the thermal damage in form of the interaction of the coating material with the gases, it is called vacuum plasma spray process. And when we fill in some of the low pressure gases, means when the spraying is carried out under somewhat low pressure conditions, then it is called low pressure vacuum plasma spray process. So, there are different variants as per the kind of environment in which the spraying is carried out, and the plasma spraying is mostly carried out for the because it generates quite high temperature. So, it suits for the high temperature materials like nickel, cobalt, tungsten, titanium, etc. can be and this zirconia kind of the material can be deposited using the plasma spray process. If as far as the performance of the plasma spray coatings is concerned, plasma spray coating properties are at par with other spray processes, but not same as HVOF and the detonation gun spray, because in HVOF and detonation spray gun processes detonation cutting spray processes, and these processes the velocity attained, high velocity is attained, and the thermal damage due to the exposure of the material to be deposited for a shorter period during the HUF and detonation gun spray processes, thermal damage is limited. So, well, high velocity and less thermal damage makes these processes much better as compared to the plasma spray process. Now, we will see the schematic of the plasma spray process, where we can see there is one tungsten electrode which is made invariably connected to the cathode, and the anode which is surrounding this cathode is basically nozzle. So, this arc is established between the electrode and the nozzle, and then plasma forming gas like hydrogen, argon or nitrogen etc. is passed through the arc zone, so that the plasma is formed. Now, this plasma is now forced to pass through the small diameter nozzle having a very smaller diameter. So, the constriction of the plasma takes place, and here only we feed the from the nozzle itself we feed the powder to our material to be coated in the plasma zone. So, here it is heated and then accelerated towards the surface of the substrate, and subsequently after the impingement with the surface of substrate, coating is developed. Now, we will take up the another coating process which is basically electroplating process. So, this is this process of coating is electroplating process. It is based on the principle of the electrolysis, primarily used for developing the coatings of the electric conducting materials on electric conducting substrate. So, means both coating material and the substrate should be electrical conducting in nature. In this process is commonly used for developing the coatings for improving the specific set of the properties using the materials like gold, silver, copper, aluminum, zinc and titanium. So, if you want to develop a thin layer of high quality material over the surface of the substrate of this kind of the material, then electroplating process is found to be good, and this can be used for improving the wear resistance, improving the corrosion resistance, and also improving the aesthetic properties like appearance or the color etc. is to be made. So, the steam value of the product can be improved. In this case, basically the electroplating process uses the electroplating process uses a galvanic cell for development of the coatings, which is nothing a big tank full of the suitable electrolyte. So, here it is full of the electrolyte which is used as for completing the electric circuit between the substrate and the material to be coated. So, there are two members, one is say material to be coated or like coating material, and this is substrate. or the component on which coating is to be applied. So, the component on which coating is to be applied is connected to the negative terminal of the power supply, and this the material to be coated is the coating material is connected to the positive terminal. So, this is made anode and the substrate is made cathode, and here the electrolysis reaction takes place. So, at the anode, the anodic dissolution takes place. Here the material, like say if this is copper on which the coating of the silver is to be applied. So, the anodic dissolution will be leading to the silver ions being produced through this electrolysis process, and these ions through the electrolyte will be moving towards the surface of the cathode, and here they will get deposited. So, the coating of the silver will get deposited onto the surface of the substrate. So, this is how. So, what are the requirements? A galvanic cell having the suitable power source, one substrate which has to be electrical conducting, and the material to be coated also should be electrical conducting, and then one electrolyte. Electrolyte of course will be having the ions of that material which is being produced, and the suitable medium, or these are basically metallic ions which are being dissolved, and the medium which is there to act as a electrolyte. So, basically there will be the charged particles in form of the positive and the negative ions in the electrolyte, facilitating the flow of current. So, in this case basically the dissolution of the material from the anode takes place, and during this process the material gets transferred through the electrolyte and deposited onto the surface of the substrate at the cathode to develop the coating. Like say if there are few projection on the surface of the component of the substrate, then accordingly, like say this is the coating and this is the substrate having a regular shape. So, this region is far away as compared to this zone. So, the regions of the substrate which are closer to the coating material, there the value of the current will be much higher to cause the electrolysis electroplating as compared to the other zones which are far away. So, here the rate of deposition will be different at the different zones as per the spacing between the electrode and between the cathode and the anode. So, this we can say this process is uses the DC power, where positive terminal will be connected to the material to be coated and the negative terminal will be connected to the substrate. Now, we will be taking up the electroless plating. Electroless plating, there is no electrolysis. This is basically an autocatalytic process involving chemical reactions for developing coating of the materials. So, like say the coating of the nickel or chromium or any other material can be deposited, but at the same time this is also used for developing coating of the composite materials. So, for this purpose, like the nickel tungsten carbide or the nickel titanium boride. These coatings can also be deposited. The coatings of the composite materials as well as the materials in metallic form can also be deposited using the electroless plating process. So, primarily it involves the chemical reactions for development of the coatings, and in this case basically the coatings of the titanium, nickel, tungsten carbide reinforced in nickel, titanium boride reinforced with the nickel can be used. In this case there is no power requirement like in the electrolysis process, where there was the flow of current and the use of the DC supply, and there is no electrode. Basically the substrate is submerged in the tank of suitable solutions, where in the chemical reactions facilitate the development of the coating through autocatalytic chemical reaction process. So, in this case basically there is a tank having the solution like this, and the component. So, this is the solution having the suitable solution here. Basically this consists of the aqueous solution of the metal to be deposited with hypophosphite. So, the metal to be deposited in aqueous solution with the hypophosphite, which acts as a reducing agent and helps in development of the coatings. So, this solution of the having the suitable material whose coating is to be deposited in this solution, the substrate component is submerged like this. So, through the chemical autocatalytic chemical reactions, the coating is developed onto the surface of the component. This may be in form of only the metallic coating, or it can be nickel, tungsten carbide, or any other reinforcing agent, but that we have to put into the solutions like in form of TiB2 or tungsten carbide. In addition to this, as far as the coating development is concerned, the coating process by the electrolysis process is slow. So, under the room temperature conditions, like if we the chemical reaction is taking place at the low temperature, say 30 degrees centigrade, then the rate at which the coating is developed is very low, that is about 1 micrometer per hour. So, considering this low rate of the deposition, the process is considered very slow, and the productivity associated with the process productivity is very low. So, in order to increase the rate of deposition and enhance the productivity, so that the sufficient production rate can be facilitated, the temperature is increased. So, say use of the temperature like 90 degrees centigrade of the solution will be facilitating the high rate of the autocatalytic chemical reactions. For increased rate of coating deposition, and this increased rate of the coating deposition helps to develop the coating at the rate like 10 to 20 micrometer per hour. So, there is a significant increase in the rate of deposition from from approximately 1 micrometer per hour to 10 to 20 micrometer per hour. So, if we see in this case, basically the chemical reactions are facilitating the development of coatings. There is no electrolysis, there is no heat, there is no thermal damage and distortion tendency, and that is why this process can be used for developing the coatings on both conducting and non-electrical conducting substrates. So, this is very good side. It can be used for developing the metallic coatings or the coatings of the composite materials on both conducting as well as the non-conducting substrates. Further, the materials which experience high thermal damage by thermal spray processes, the coatings of those materials can be effectively deposited using the electroless plating process. So, those materials which experience significant thermal damage during thermal spray processes, then this process can be effectively used. Conversely, if we say when the thermal spray process cannot be used for developing the coating of particular material onto the substrate, then electroless process can be used for developing the coatings. Now, I will summarize this presentation. In this presentation, basically I have talked about the plasma spray process, electroplating process and electroless plating process. Plasma spray process results in a very high temperature of the plasma during the spraying process. So, that has the tendency for thermal damage as compared to the other thermal spray processes. At the same time, electroless process basically uses the chemical reactions for development of the coatings, and there is no thermal damage. It can be used for both conducting as well as non-conducting materials. On the other hand, electroplating process can only be used on the with the conducting materials only, and this is how we complete complete all the coating processes and all those methods wherein layer of the suitable kind of the material is deposited onto the substrate for improving the properties of the surface, so that the tribological life of the component can be increased. And under this we have talked about the weld surfacing, thermal spray processes, electroplating and electroless processes. Thank you for your attention.